Okay, in this video I'm going to go through the recursion and finance section. Okay, Jason runs a landscaping business. The value of his van can be depreciated using the flat rate method of depreciation. The value of the van in dollars after n years can be modelled by the following recurrence relation. Okay, so here's our recurrence relation. This is a yearly thing. So I've seen that it's flat rate, and I'm going to look at that flat rate part of my summary sheet. So what is the annual depreciation in the value of the land? So that is actually, if you look at D, is the amount dropping per period, and because this is written in years, so we can see that that is it's dropping by $4,400 every year. Okay, calculate the annual, so they want the annual flat rate depreciation rate of the van. Write your answer thing. So if you look up there, you can see that D, which was 4,400, is found by using the rate times 100 over 100 times VO. So if I substitute that into that formula, the rate is what I want to know, and I know that the car was initially 32,000. So you can use this and do the solve, comma R if you wish, and we will work out that the rate is 13.75%. Okay, use recursion to show that the value of the van after 2 years, V2, is that. So when you need to use recursion to show, you need to show like this. Hi Jacob.
Hi.
What's up?
I just need some help with question 12F, if that's okay.
12.
No, question 3F, not question 12, my bad.
In section 2?
Yeah.
Yeah. Alright, sorry, I'm just getting it up. Section 2. Which question? 12 what?
F.
You don't...
No, question 3. I said question 3.
Sorry.
12 by accident.
Yep, 12.3, question 3. Sorry, just going to it. 12.3, question 3. Yeah. So you'll need to use your formulas.
Yeah, I took a photo of the thing.
And which one do you want? F?
F, which is a trapezium.
Yeah. So, I'll just share screen. I'll do it on the iPad.
Would I just do 5 point...
So the I can't remember how your...
Isn't it 2 plus 5.5 times 3 divided by 2?
Yeah, hold on a second. Sorry, I'm just... So you need to show the step by step. So you'd go V1 equals, say, 32,000 minus 4,400, and you'd write the value there, which would be 27,600. Then you have to show that V2 equals that 27,600 minus 4,400, which equals 23,200. So you need to show that to get the 1 mark. The van after 2 years was Okay, the value of the van also can be depreciated using unit cost method. So I've gone and got the unit cost formula. And the rule for the value of the van after travelling in kilometres is this rule here. Okay, what is the depreciation of van per kilometre? So you can see in the formula it's that little d bit. So here we can see that is 0.22. So we're going to say $0.22 or 22 cents. So after 2 years, the value of the van will be the same when depreciated by the unit cost method or the flat rate method. How many kilometres has the van travelled after 2 years? So if you looked before, they said, the van after 2 years, V2 was 23,200. All right, so if we're trying to see what the unit cost would be, or how many kilometres it's travelled, what you want to do is you're actually trying to find, V2, you've got the V2 part of the formula. So I'm looking up here. We know that it was 32,000 to begin with, minus n's what I want to know, and I know that D is 0.22. But I know I'm using V2, so when it's V2, I put that in, and here's another one. I just can put the n there, and I can use solve again, and comma n, and I can find out that it would have travelled n equals 40,000. So how many kilometres? We better write the statement out of 40,000 kilometres. Sorry, my mic was just off for that. So what I did do when they asked me to go for the recurrence relation, I found compound interest investment, because that's what an annuity is. And I've used this formula up here, and you can see when I needed to find the R over here, so I worked that out, and I know that goes into that part of the formula. And D I saw was the regular payments, and I've could see that was up here, and I've popped that in. To find after 10 years, I just use Finance Solver, because remember it's 4 times a year, so 40 into the n, and it said the nearest cent, so we've summarised that. Okay, find the interest Jason would earn in the investment during the 10th year. So it's very important to read that. So during the 10th year actually means between the 9th and you get up to the 10th. So it's probably good to find the final value at the 9th and find the final value at the 10th and see how much the investment has gone up in that year, in that timeline. So if you have a look here, I've calculated here is the 9th year, and I've used the FE, and here's the 10th year. So if I do the 3692.10 minus, so this was the 10th year, minus the 9th year, 138,558.87. So if I do that on the calculator, you can see that it's gone up by 15,133.23. So that's how much it's gone up. The final value has gone up. But you've got to remember into here, he made, because it's in 1 year, he was also contributing 4 payments of 2,500. So that's not how much the interest has added on. He's added that in himself. So really what we've got to do is the 15,133. So it's the change in the value, but we've got to minus those 4 payments, which would be $10,000, because 4 times 2,500. So you end up with 5,133.23. That's how much interest he has earned in the 10th year. Question 9. Jason and his brother each receive an inheritance of $125,000. Jason invests his $125,000 into a perpetuity. So I just put up a perpetuity on my formula sheet, which earns an interest rate of 2.4% per annum and is calculated on a monthly basis. So I just write PPY 12. What monthly payment will Jason receive? So you can see here, I've put what to put into Finance Solver. So when we're trying to find the payment, in a perpetuity, the balance always stays the same. So you can see that here we said the FV equals a positive PV. So we always just need to put one month or period in, because it's never going to change, it's always the same. And I put the 2.4. Now he's investing into the bank, so it's 125. That will be my question. And we know that the FV will be the same amount at the end of the month. So really the bank's going to give me back my money because I'm going to take the payment of interest out. And this was monthly, so PPY is 12. And you can see, so I've worked out that his monthly payment would be $250. Liam invests his $125 in an annuity, which earns an interest rate of 2.13% per annum and is calculated and paid monthly. The balance of Liam's annuity at the end of the first year of the investment is this amount. What is the monthly payment that Liam receives during the first year? So this is an annuity. So this is where his payments are slowly coming out, and the investment will diminish down to 1 eventually. So they wanted, its PPY is 12, and they want it in the first year. So you can see N is 12. The interest rate I've popped in, 2.13. Now he's still investing, so it's a negative PV. The payment is what I want to know. And at the end of the first year, the bank is going to give back that much. So we pop that in as a positive into thing and PPY 12. And we can see that he gets a payment of $5,300 a month. Okay. The balance of $63,464 and 6 cents is to be fully paid out to Liam with a further 12 monthly payments. The first 11 payments will be $5,350. The 12th May payment will be different amount to ensure the annuity is paid out to the nearest cent. What is the value of the 12th payment? So what you want to do is you still want to go to the 12 period. So you can see here for the next year, I'm still going to find out I want to find out what the value at the end of 12 years. And this is how I do it. So I pop it in and I've got the interest rate. Now it's like he's investing. So this becomes a negative PV. And I put in his payments. Now he's getting them back out to himself, so they're positive. So they're positive, and PPY is 12. And you can see that at the end of that year, the FV is a negative I'm going to round 36. So when it's negative, that means you still owe the bank. So I still owe the bank, I owe the bank, I've withdrawn too much, and I owe the bank $1.36. So what I can do, instead of taking that 12th payment of $5,350, I will just minus that $1.36, so that I don't have to pay, get the payment and then give back the bank $1.36. I'll just tell them, just make the payment a bit shorter. So we've got 5348.64, and that's the answer. Question 10, Liam takes out a business loan. So now we're on a loan of $340,000. The interest loan is 5.2% per annum, compounding quarterly. So I'm just going to write these. This is PV, and it'll be positive. That's the interest rate. PPY is 4. Liam will make a repayment immediately after the interest has been charged. They're always going to say that each quarter. During the first year of the loan, Liam will make interest-only repayments for each quarter. So when you see interest-only, put it up here, you have to remember that PV and FV will always be the same because you're never paying anything off, you're just paying the interest that you charged. So how much are his interest-only repayments during the first year? So you can do it a couple of ways. The payment up here, if you look at the formula, is we can work it out like that. So D is the payment, and I do the rate, which is 5.2, divided by PPY, which is 4, over 100, times the VO, which is 340,000, sorry. And we will get a value of 4,420. So that will be his every payment. For the next 2 years, the loan, Liam will make quarterly repayments. So now he's making quarterly repayments of 28,000. So if he's going to give back, that's going to be the payment, and it'll be a negative, this 28,000. The interest rate will be different to that of the first year, and at the end of the 2 years, the outstanding balance of the loan will be this. So that actually has to be a negative FV because you still owe the bank. And what is the interest rate during these 2 years? So remember, we've got 2 years at is it still quarterly? Yes, still quarterly. So PPY is 4. So 2 years times 4. So you can see that's where I got the 8. I'm trying to work out the interest. The PV, because remember, the PV is the 34,000 still, because the first year it was interest only. So he still has the same amount for the loan. So we're going to say 340,000. Then we've popped in the payments. We've said this is what it'll be at the end of the 2 years, and PPY is 4. So we go up there and we can see the interest rate is 5 it says to 1 decimal place, so 5.1%. With an outstanding balance of the loan at 142,000, so this is what he still owes, the interest rate of the loan is changed to 4.9% per annum and still compounding quarterly. So when you've still got a loan to go, we're going to pretend this will become our new PV, and just pretend like it's the beginning of a loan, so it'll be positive. This here is my interest, and PPY equals 4. He's still going to make payments, so I've got a payment which is also going to be negative when you are paying back a loan. How much interest will be charged during the next year of the loan? So once again, N will just be 1 times 4. Sorry, we've missed that there. And you pop in the interest rate we've got there. We've popped in the positive PV. We've put in the negative payment. It says how much interest will be in the loan. So we really need to know the final value at the end of the year. So we do that. That's what I'm looking for, PPY. So the loan has gone from 142,012.69 and has dropped down to, he still owes 35,025.37. So if you look here, this drop here, it's dropped down. I'm going to work that out by just going 142,012.69 minus the 35,225.37. So this is going to tell me the drop in loan amount. So the drop in loan amount was 106,987.32. So that's how much the loan has dropped. But if you think about the amount he's paid in, they've paid off really because it's 1 year, 4 payments of 2,800. So when you work that out, of 28,000, 4 payments of 28,000, which equals 11,200. So what they've actually paid is this, and what it's dropped by is that. So the difference in that, so interest equals the amount paid minus the drop in value in loan or whatever. So it'll be 11,200 minus the 106,987.32, which equals 5,012.68. So that's the amount it's dropped by. Sorry, that was the interest. So there's the interest that you were charged in the year.